Alright, so the next thing we want to take a look at now is going to be static class members. So again, remember that class members means all of the fields and methods of a class. So specifically what we're going to be looking at now is fields and methods that use this static keyword. So static class members are going to be members that belong to the class rather than individual instances or objects of that class. This means that all objects will share the same values in these static members. For example, all objects of a class will have the following static field, which is going to start off at a value of 0 and they access that member. In this case, we've got our private static int instance count, which is going to be initially equal to 0. So you see that we have that static keyword put into our set of keywords when we're declaring that variable. Additionally, if that value is ever changed using one of those objects, all other objects will observe the same change. So they all share this particular field that we have right here. So the following code is going to add a line to the noargs constructor of the rectangle class to go ahead and just increment this instance count. So in this case now we can go ahead and keep a count of the number of instances of the object that we are constructing. So in this case we're showing with just the noargs constructor. If we come back over to our rectangle class that we've been working on, we know that we have a couple of constructors, so we'll need to do this for a few of them if we want to go ahead and capture the same behavior. So we'll go ahead and minimize this, come over here. So in our noargs constructor, we want to go ahead and include that extra line. In order to do that, we want to make sure that we add this extra field. So we're going to do private static int, we'll call it instance count. It's going to be equal to 0. So we've added this extra little portion right here, this keyword static, to indicate that now instance count is a field that belongs to the rectangle class rather than objects of the rectangle class. So then right here, if we go ahead and increment it, so we're going to say, let's do this dot instance count, do plus plus to just go ahead and increment that value. Additionally, because of the fact that we did mention in the previous video about using the this keyword to be able to distinguish between our fields and our parameters, for its own sake, just to be complete with this, let's go ahead and add that to length and width even in our noargs constructor. So that way then everything inside of this will go ahead and match up by specifying the fields with the this keyword, and then that's kind of consistent throughout most of the program. I'll cover it in a moment when we get to some of the other methods. In addition to this, we can go ahead and include that for our parameterized constructor. So we'll do it right here as well. Say this dot instance count plus plus. Go ahead and save that. And then when we come over to our other constructor that we just created in the previous video, dealing with the this reference for our constructors, because of the fact that we are calling the other parameterized constructor when we do this, right here in line 25, that's going to have to step through all of the lines inside of that constructor. So it's going to initialize the length and width, and it's also going to increment the count right here. So because it does that, we don't have to worry about including that in this one. It's already covered because of that call for us. And then carrying on with the other methods in this, just to kind of clean up from what we saw from the previous video, we've got our length right here. So we'll say return this dot length to specify that it's the field. Same thing with this one. We're going to say return this dot width. And then finally in our area, we're going to go ahead and say that we want to return this dot length times this dot width. So of course, all of these additions right here don't have any effect on the functionality of this program. It's primarily just done to make it even more readable. That way then we can very easily and immediately recognize which variables correspond to the fields and which one correspond to parameters. So save all that. We'll come over to our rectangle demo. So inside of the rectangle demo, we've got 3 different constructions that we've included. So we had this construction of a rectangle called rect, took the noargs constructor. We then have our box, took 2 values, so that was using the parameterized constructor. And then this last line for room, again, took 2 arguments, so again used the parameterized constructor. to be able to demonstrate with one more of these, we're going to do rectangle. Let's go ahead and call this one square. So this is going to be equal to a new rectangle. And for this one, I just need to give it a single value because I'm going to make use out of this newly added constructor right here. So I'm going to give it a single value, and what it's going to do is take that single value with this call right here. So it'll come over to this constructor, and it's going to go ahead and apply that value to both the length and the width field, and then also increment instance count. So right here, we can go ahead and put this in. So let's say something like, let's do 7 for this one. So now we're going to go ahead and create a rectangle whose length and width are both 7. So it's effectively a square. And then later, if we want to go ahead and access that instance count, we want to be able to go ahead and just grab that and print that out to the console. So in order to do that, we're going to need to add a get method for it. So let's see what happens when we try to put that in. So let's say after get area, at the very bottom of this, we'll go ahead and do something like public int get instance count. And right here, we want to go ahead and return the instance count. Okay. So we can go ahead and save that. So no issues. Go ahead and come over here. And at the very end of this, so keep in mind, we're going to go ahead and increment that every time we construct a rectangle object. So we're going to do 1, 2, 3, 4. So if we go ahead and print this out, we want to see that value of 4. So let's say right here at the very end of this program, we'll go ahead and just create 4 different print statements, one for each one of our objects. We're going to do rect, box, room, and square. And we want to go ahead and get the instance count for every one of those. So go ahead and do something like this. I'm just going to go ahead and copy this line and paste this down 3 more times. So we've got our rect, then have our box, our room, and our square. Go ahead and save that. And so the expected output for this is going to be that because of the fact that the instance count is constantly being updated and all the objects are observing this update, all of them will hold the value 4. So if we go ahead and run this, we can see right here at the very end, for all 4 of our objects, they're all printing out the value 4 to the console. So everything looks good, but there's one slight problem as far as the logic of this program is concerned. So the output is correct, but the way that we're getting it, the intent of it, doesn't really match up with the purpose of instance count. The purpose of instance count is to track the number of instances of my objects of this class. So it's not really something that should be associated with a particular object like this. Ideally, it's something that we go ahead and check with the class as a whole. What I mean to say by that is that we don't really want to use this object.getInstanceCount. Instead, we want to be using the rectangle class itself .getInstanceCount because we would just want to check the number of instances for the rectangle class as a whole. So to do that, we're going to take a look at the other type of static class member, which is going to be the methods. So static methods are going to be called on the class itself rather than objects of the class. These methods are going to be useful for utility functions rather than methods that need to manipulate or access data in objects. So in addition to maybe being able to access some kind of static information, like what we're doing with what we intend to do with this instance count, we can also use it for a utility function. Say, for example, in this one right here, we've got this public class called metric. We then go ahead and create a method called miles to kilometers, where it's going to take some miles, multiply that by 1.609 to then convert it to kilometers. So if we're doing something like that, that's not really something that deals with the data of a particular object. We don't really care about trying to manipulate or access the data in an object. All we really care about is just doing a very basic sort of general purpose conversion. So in that sense, because it's like a utility function, we want to go ahead and just use the static keyword. So instead, we're going to say public static double and then miles to kilometers, and then we'll pass in the double miles, do all of this. And so now, whenever we call it, we're going to use the metric class itself. So we'll say metric dot and then miles to kilometers, and then we give it that value of 10.0. So if this format right here looks kind of familiar, you might be thinking of some of the methods from the math class. like say math.pow or math.sqrt, square root. Those are other examples of utility functions where there's not really some object of the math class that you want to try to manipulate the data of. Instead, you're just using the math class to perform some kind of general purpose utility function, like getting the power, like the exponent of a particular number, or getting the square root of a number. So let's go ahead and incorporate something like this into our program as well. So go ahead and minimize this, come over here. So two different things that we'll go ahead and take a look at right here. So one of those is to modify our get instance count so that it's static. So we're going to go ahead and change this to be static. Go ahead and save that. And of course, once I do that, we can still go ahead and do this. It's totally fine, but it will give us a little warning telling us that we're accessing the static method get instance count, which doesn't really make sense as something to do with an object. You can do this, but it's not really recommended. Instead, we want to just go ahead and use it on the rectangle class itself. So now it'll stop giving us that little warning about it. And so now if I go ahead and run this, I'll still get the same output, but now the intent or the purpose of getting that output has changed to be something that's a little bit more sensible. So if you run this, we can see that value 4 printing to the console. Go ahead and close this so we can still see everything. So in addition to this, I'm going to go ahead and include another static method, something that I can use as a sort of utility function. What I want to go ahead and do is create another getArea method, but this one's going to be used by just passing in a length and a width, so you can just immediately calculate the area of some rectangle kind of on the fly without necessarily having to create a rectangle object. So we're going to do public static double, call this getArea. So because this is not going to use a rectangle object, that means we don't have a length and width field to access. We need to go ahead and pass the values in for the length and width. I'm going to say double length and double width. And then right here, we'll just go ahead and return the length times the width. And so of course now the key distinction here inside the body is that we're doing length times width corresponding to the two parameters and not this dot length times this dot width, which would correspond to the two fields of the object of the class. So now if I go ahead and do something like this, I can come back over here. So let's say maybe I want to go ahead and grab something like this line right here. We'll go ahead and make some modifications to it to be a bit more general purpose. So we'll go ahead and say something like system.println, the area of the, let's say new rectangle is, and we're going to go ahead and call the rectangle class. So we're going to put rectangle.getArea. And so now it's going to give me a warning since the getArea, the static one that I'm going to call on the class itself, is expecting 2 values. So we'll go ahead and give it 2 values. Let's say something like 6 and 9. So we'll go ahead and get an area of 54 for this one. So if we go ahead and run this, now we can go ahead and just immediately calculate the area of some new rectangle just on the fly without having to create a rectangle object to do that. So just go ahead and give us that area of 54. Then one last thing to mention is that the this keyword is available to use in all of our non-static methods. So all of the methods that we'd seen prior to this could use that this keyword. Since the this keyword is meant for an object to reference itself and static methods belong to the class rather than objects of the class, the this keyword is not really compatible with static methods. So the purpose or the intent of static methods isn't really to manipulate or access data in the objects, so it doesn't really make sense to be using the this keyword inside of them. So it'll be restricted to just the non-static methods. Okay, so at this point, this is going to wrap up everything for our static class members. In the next video, we'll take a look at how we can start using our objects alongside our methods. So how we could go about passing objects into methods or returning objects from methods.